So as I explained earlier, what I did was I took a normally aspirated distributor, cut 3 of the vanes out of the rotor, and I cut the top off the shaft, and then threaded in a sensor through the side, and that way I can get my spacing to the vane, whatever I want it to be. And that looks like it'll work. I keep having to reshoot this portion of the video because it keeps losing sound or something happens. I lose the display. Anyway, I think I got it set up. So on our wiring, I've got my hot going to the brown. My black is my signal, and that's going to the negative lead of the meter. Hot's going to the positive lead of the meter, and then my ground from my power supply is going to the blue. And then between the positive and the signal wires, I have the 1K pull-up resistor. That's to strengthen the signal that we're going to see. So my distributor, I think I've gone over it enough before. I've got the Hall effect sensor from DIY Autotune. 3 vanes are cut out of the distributor. I've got 1 vane left, it's solid, and I've cut the top of the shaft off so that I've got a flush area here. It's not going to interfere with the plate. So as I turn the vane, when it lines up with the sensor, it goes high. So it's 13.5 volts. And then as the vane starts to leave the sensor, it goes to 0 volts. So that's the signal I'm going to use for my microsquirt, and that'll be the input for the cam sensor. So it stays 0 until it sees the vane, goes high, and then when it goes back to 0, that's when the microsquirt's going to acknowledge that the cam is in position. Now again, getting the timing of this right is partially going to be due to the position of this vane, so it could be, depending on the shaft position, 180 degrees off, but you can also fudge in the degrees from being in position on the software. So there's 2 ways to do it. One is by the actual position of the distributor, and then the other one is by offsetting the sensor software where it's going to be. So hopefully that makes sense. Hopefully this is the last time I've got to shoot this thing, because before the distributor, what I did was take a normally aspirated distributor. There's 4 vanes on this disc, on the shaft. I cut 3 of them away using a Dremel tool, and then I drilled a hole through the side, mounted my sensor. It's a 1/2 inch hole. And to mount, I wanted to put a coil pack on top. This came from a Caravan out of a 2.4 liter. So I threaded these 4 screws bigger, 4 holes, made a plate that fit, and then a plate for the coil pack, and that's going to be my setup. Now I've got the coil pack centered weight-wise right over the shaft, so that I think will work. I don't expect to have to adjust the rotation on this at all. Maybe some minor changes depending on how the shaft mounts, but I've got 180 degree ability. If I have to tweak it a little more, I can always make up a new wheel if I have to. That's my setup. Unproven, but it's a start. I got this coil pack from a Dodge Caravan, and I wanted to test that it's actually a good one. So I found online how to test it. So essentially, you go to the 200 or low ohm scale because you're looking for a 1 volt signal, or ohm signal. And on your input wires, you're looking at the center wire, which in this case is green-red, to an outer wire, and the center wire to an outer wire. So both of those readings should be about 1 ohm and no resistance. So center wire being green, and you can see I'm about 1 ohm. And on the other wires, about 8/10, 7/10 of an ohm. And if you go between the outer two wires, you also get about 1.5, 1.3. So it's not much different. But that tells you that your one set of coils is good, and then you've got to check the other set. So you've got to go high resistance, so go to 200K, and then go across the 1 and 4 and the 2 and 3. So 1 and 4, I'm getting about 12.2 K ohms, and the other one's 12.3 K ohms. So that shows that both of these coils are good, and the windings on the inputs are good. As I always say, if you're removing parts from a junkyard or pull-it yard, make sure you get some wiring with it. Don't just take the connector off and leave it. So in this case, if you want to take the connector off, you push the red pin, the lock pin out, and then you just push on the center tab, and it comes apart. So you got 3 terminals in there. Locks it. So pretty easy to test. So now I have a working distributor, hopefully. Actually, it's not a distributor, it's a coil pack. But I've got my sensor and the coil pack, and I can just wire these into the microsquirt, this one to the microsquirt, to the tack sensor, and I have to figure out which orientation my shaft has got to be in to make it work. So I'll get that down the road, but right now it's looking good. I'm not going to bother waterproofing this, put a seal on or anything, because there are holes in the bottom. You can see those. So if there's any water that gets in there, it'll leak out those holes. Not a big deal. There's nothing in there moisture-wise that I'm worried about. Worst case, it would come down the shaft and get into the oil pan, but I don't see that much getting in. So we should be good to go. That'll do it for this week's video.